Okay, we are doing solving absolute value inequalities. It's a lot like, it's a mixture of what we've, like our last two lessons. Okay, so things that you need to know when solving absolute value inequalities. There are and or problems, but it doesn't tell you and or, so you have to be able to figure that out. And the best way to do that is that less than or equal to, we will say less than, because it's an and problem. Now this is only when your absolute value is first. Greater than or equal to, we call great or, because it's an or problem. Okay, and just like yesterday, when you have absolute values, the first one, because today we're doing inequality, so first inequality, equality is exact. My second inequality is opposite sign and negative. I'm going to show you what I mean by that in just a second. Now remember, both of these are with no absolute value bars. No absolute value bars. Okay, we know that any number, the absolute value of any number, is always a positive number. So if I have the absolute value of any number, and I have any inequality sign, doesn't matter which one, and a negative number, we're going to stop because it's a special case. Okay, so we know that positive numbers are always greater than negative numbers. This will all make sense in a second when we get started. So if we get something like that, it's all real numbers, because this is always true. But if we got a positive number is less than a negative number, is that true? No, so then that would be no solution, because that's false. Okay, other than that, our steps are just the same as yesterday. So is my absolute value on number 1 alone? No. So what do I need to do to get it alone? Because that's my first step. Plus 4 on both sides. We have to get rid of that minus 4. The way we get rid of minus 4 is the opposite, which is plus 4. So now I have 1/2 x minus 3 is less than 6. Now is my absolute value alone. Okay, so now I rewrite it. I rewrite it exact is less than 6, and then I also rewrite it 1/2 x minus 3, flip my symbol, negative 6. Any questions with what I just did? So step 3 yesterday was to solve both. So I'm going to add 3 to both sides. I get 1/2 x is less than 9. How do we get rid of a half? Multiply by 2. Guys, when you have a fraction, you multiply by the reciprocal. The reciprocal of 1/2 is 2/1, and 2/1 is just 2. So we can multiply both sides by 2, and I'm left with x is less than 18. Let's put that away, please. Maria. No, 1 minute. I don't need your finger held up. You can come put it in the basket. So plus 3 on both sides. And I have 1/2 x is greater than -3. Multiply both sides by 2. And I get x is greater than -6. Because it's an inequality, we have to graph it and put it in interval notation. However, we look at our symbol from right before we separated. Here's where I separated. Here's right before I separated. What symbol is that? So it's a less than problem. So this is an and graph.
What is that, Miss?
Remember and or? This wasn't yesterday. This was this. Because and is where they overlap. Or is anywhere you shaded. Overlap. Anywhere you shaded. Okay, so knowing that, if it's an and problem, it's anywhere I shaded. I have -6. I mean, sorry, it's only where it overlaps, and then I have 18. I know that this is my negative infinity and positive infinity. Okay, x is less than 18. And x is greater than -6. Greater goes to the right. They both get parentheses because neither of them are equal. And because it's an and problem, my solution is where it overlaps. It starts overlapping here and stops overlapping here. Not a part of my solution, not a part of my solution. So it's everything between -6 and 18. Any questions with that one? Okay, so look at example 2. This is the one on the practice yesterday, except it's an inequality versus an equation that a lot of y'all struggled with. So it's a good practice problem. First things first, is my absolute value alone?
Yes.
Yeah, I have my absolute value. I have greater than or equal to 6. Okay, that whole thing is in the absolute value. So I'm going to rewrite. I have 3 minus x over 5 is greater than or equal to 6. And then I have 3 minus x over 5. Flip my symbol, -6. So again, remember we look at our symbol right before we separate. What kind of problem is this? Well, that's a greater sign, so it's great or. So it's going to be an or problem. Okay, how do I solve this? I have to multiply both sides by 5. On this side, the biggest mistake I saw is people would cancel, but they would still distribute. If you cancel and distribute, you technically multiplied it by 5 twice, which is multiplying by 25. Is that what I'm trying to do here? No. Once you cancel it, do not multiply. So we just have 3 minus x is greater than or equal to. Now this side, nothing cancels, so I do actually have to multiply it. What's 6 times 5? 30. Now I'm going to subtract 3 from both sides. And I get 27. Now what? Am I allowed to have a negative x? So I need to divide both sides by -1. And I get x. I have to flip my symbol. Why do I have to flip my symbol? because I divided both sides by a negative, and I get negative 27. I'm going to do the same things over here. I'm just going to get a different number on the right. So I'm going to multiply by 5, cancels. 3 minus x is less than or equal to negative 30 this time. Minus 3, and I have negative x is less than or equal to negative 33. Divide by negative 1, divide by negative 1. I have to flip my symbol because I divided both sides by a negative. And I get x is greater than or equal to positive 33. Okay, so I have negative 27, which is smaller than positive 33. And x is less than or equal to negative 27. Less goes to the left, equal to gets a square bracket. X is greater than or equal to 33. Greater than goes to the right, and equal to gets a square bracket. And because it's an OR problem, our solution is everywhere we shaded. So we shaded here, and we shaded this way. So all of that's a solution. However, there's a gap in the middle, so remember we use that U for the gap. So it goes to the left forever at negative infinity. That piece stops at negative 27 with a square bracket. There's a gap, so we use the U for union. Picks back up at 33 and goes to the right forever for infinity. Okay, I know it looks like a lot on the back, but 2 of them are special cases and are pretty simple, so we're just really doing like 1 more all the way through, and then we have 2 special cases. Okay, so look at number 3. Is my absolute value all alone? Yeah, so it's ready to separate. Before I separate it, I'm going to pay attention. What kind of symbol is that? Less than, so it's a less than, so it's going to be an and graph. And I know I have to rewrite it twice, so I have 3 over 4x minus 5 over 2 is less than or equal to 13 over 8. I have 3 over 4x minus 5 over 2, flip my symbol, negative 13 over 8. Now what's gross about this problem? Fractions. Now you could solve it with fractions if you want, but do you want to? Most people don't. So looking at my denominators, I have 2, 4, and 8. My biggest number is 8. Can 2 turn into 8? Can 4 turn into 8? So 8 is my common denominator. Does it always work that way? No. Okay, but on this one it did. How can I turn a 4 into an 8? Times 2. So what I do to the top, the bottom, I have to do the top. Well, I'm going to do that on this equation as well. What I do to turn a 2 into an 8? As long as I do it to the top, it's still equal. I'm just unsimplifying my fraction. Now, without even rewriting, are all my denominators equal to 8? Yeah, 4 times 2 is 8, 2 times 4 is 8, and this one already has an 8. So I'm just going to cancel my denominators now. But I'm going to rewrite the top to solve. What's 3 times 2? So that has an x, so 6x minus, what's 5 times 4? Is less than or equal to, the 13 didn't change. 3 times 2 is 6x minus 20, greater than or equal to negative 13. Now does this look like something that's easier to solve? Okay, so let's solve it. I'm going to add 20 to both sides. And I get 6x is less than or equal to 33. Divide both sides by 6. And I get x is less than or equal to, well, here you can divide it or you can write it as a fraction. 33 divided by 6 does give you a pretty decimal, or you can hit math, enter, enter, and you get a fraction that's simplified to 11 over 2. I usually leave minus fractions. However, it is good sometimes to know what it is as a decimal, and I'll explain why here in just a second. So on the other side, we're pretty much going to follow the same steps. Add 20, add 20. I get 6x is greater than or equal to. Now this gives me 7. I'm still going to divide both sides by 6. And that doesn't simplify. I get x is greater than or equal to 7 over 6. However, if you divide 7, divide 6, does it give you a pretty decimal? So on this one, I would not accept a decimal because it's 1.6 or 1.16 repeating. The 6 is repeating, not the 1. However, it is important on this one to know what your fractions equal because they're both positive. Usually one of them is negative, so it's really simple to tell which one's less. But if you're like me, I can't just look at 11 over 2 and 7 over 6 and be like, oh yeah, this one's smaller. My brain doesn't work that way. So which one of these is smaller now that we know the decimal? The 7 over 6. 11 over 2 is bigger. And it's an and problem, so we want them to overlap. However, we need to double check that they do overlap. X is less than or equal to 11 over 2. Less goes to the left. Equal to gets a square bracket. X is greater than or equal to 7 over 6. Greater goes to the right. Equal to gets a square bracket. And it's an and problem, so where they overlap is my solution. So this piece and this piece are not part of my solutions. Any questions there? Okay, look at number 4. What do I need to do first? Subtract 6 from both sides. I get 1/3 x plus 7 is less than or equal to -1. What do we notice? It's a negative. When I told y'all, anytime you have a negative after your absolute values alone, you stop. Now, we know that absolute values always give us a positive number. Is a positive number less than or equal to -1? No. So this is false, meaning there is no solution. So to graph this one, it's literally just an empty number line because there's no shading. This is why you want to pay attention when there is the negative, because you can do all that work just like we did before when we just had linear inequalities and you'd still get the same answer. Do you really want to do all that work if you don't have to? No. Okay, look at number 5. Well, it's negative. So we stop. This is going to give me a positive number. Is a positive number greater than -5? Yes, this is true. Because even 0.00001, okay, is more than -5. Right? So this is true, meaning there's all real numbers. And when I graph this on a number line, it's going to be shaded everywhere. Because everything is a solution. Okay, there is a couple things on the practice I want to talk about before I let y'all go. It's not that bad. Look at number 1. Here, there's a lot to simplify inside the absolute value bars. Y'all, make your life easier. Simplify it before you break it apart. Yes? If you break it apart, then you have to simplify it twice. Do you really want to do that if you don't have to? No. So if the inside of your absolute value bars can simplify, simplify them before you break it apart. Yes? Should I stop on this one and say no solution are all real numbers? No, why not? Because my absolute value is not alone. Okay? So do not stop and tell me no solution are all real numbers until this absolute value is all the way by itself. Yes? Okay, and then look at number 6. Now, yes, this is a less than symbol, but it is not an and problem because my absolute value is not first. So if I need to rewrite it, the mouth is eating my absolute value, so I have to flip my symbol when I rewrite it. So be careful with that. So this is an or problem. I do have an answer key up here. You do have today